2D शेप्स के आपको याद करने पड़ते हैं, 3D शेप्स के आपको गिवन होंगे। एरिया एंड perimeter. Area is the covered region, perimeter is the length of the boundary. For example, if we talk about this shape and I call it a square, so the area, formula of area is length square and perimeter is 4L. You add all four sides. If we talk about this shape, that's a rectangle and it is length into breadth as the area, and perimeter is adding all four sides, 2 times length plus 2 times breadth, length plus breadth. If we talk about a triangle and this side as perpendicular with the base, area is 1/2 times base times this perpendicular height, and perimeter is sum of all three sides. Let me call them A, B and C. We keep on changing shapes. Let's say we talk about the trapezium. Now this is 1/2 into sum of parallel sides. Let me name them A and B times height. Now height is always the distance between two parallel lines, and sum would be sum of all four sides. Some people feel comfortable writing it this way: side 1 plus side 2 times height makes no difference. When we talk about the parallelogram, the formula is this length multiplied with the distance between these two parallel lines. So that is length into height, and the perimeter is again all four sides. So if we keep on moving and I say that a square or a rectangle is being attached with a triangle, now we call this composite shape. In this case, you always solve the two shapes separately, and obviously we know that the first one is a triangle, so we'll write 1/2 into base into height, plus the second one is a rectangle, length into breadth. So this is my area. In case of perimeter, find these 1, 2, 3, 4, 5. So A, B, C, D and E, all 5 sides, and you will skip this line which is at the center. Perimeter is always the sum of the boundary. Bringing this to a new shape, circle, area and perimeter. Area of circle is pi r square, perimeter or circumference of circle is 2 pi r. Few books they do this with the diameter. You can write pi d or you can write, but that's a little longer, so I would suggest you go with the radius. And when we talk about the semicircle, area of semicircle would be pi r square. Anyone, what would be the perimeter of semicircle? Area is pi r square by 2. Pi r, this is half of it. There's more to it. Plus d. Now look at this. First we had all of this. It moves around 360 degrees. But now this is half of that 180 and this new shape 1, 2. So either you write d or you write pi r plus 2r. 2 times radius appears as new shape, new side. Now if I talk about this quarter, 90 degree must be given to call it a quarter, and this is pi r square complete circle divided by 4. But in case of perimeter, this complete circle was 2 pi r and it is 1/4 of that plus 2 times radius, one radius and the second radius. So 2r. Definitely we would need to simplify this. This is pi r by 2 plus 2r for the quarter. Now what happens when an angle appears there? For example, we have a sector, angle is theta. Now this is part of this complete circle, so it is theta out of 360 times pi r square. In case of perimeter of the sector, this is the arc length. It is theta out of 360 of the complete circle, first thing, plus 2 times radius 1 and 2, so plus 2r. Now I'm going to try and change these shapes into 3D. Let's say we started with the square, and once we move towards 3D, we will be talking about volume and total surface area. First we had a square. If I try to change it into 3D shape and call it a cube, so volume is length into breadth into height. In this case, because it is a cube, all sides are equal, so I can write length cube. And total surface area, one of the face is a square, which is length square, and we have 6 such faces, so this becomes 6l square. Second shape is a rectangle. Turning this shape into a 3D shape, volume is length into breadth into height and total surface area. Now we have 6 faces. If I talk about the first, let me label this as length, this is breadth and height. So if I talk about the bottom, that is length into breadth, which is actually 2 times. The top face and the bottom face both are same, plus the face on the right side is breadth into height, which is again 2 times. It is on the left as well, and the two faces left, this in green at the back and at the front, is length into height, and all of this is 2 times. Total surface area of cuboid. Then the third shape was a triangle. I'm first carrying out the regular shapes. We will go into irregular ones later. So if I change this into a 3D shape, now what happens? In case of volume, area of base, always area of base or base area times the height or times length. But if we go back to this cube, this base area is actually length into length, which was length square, into this third part, again length is L cube. And if we talk about the rectangular shape, base area is length into breadth, length times breadth, and height is h, this becomes LBH. In this third shape, area of triangle is 1 by 2 into base into height times this length. This is the length between these two regular cross sections, these two shaded cross sections. You may call it length, you may call it height, makes no difference. Do not mix these two heights. First height is the height to find the area of triangle, second height is the distance between these two shapes. And total surface area, I can see 5 faces, 2 of the triangles, 1 by 2 into base into height, if I may label them 1 and 2, and then I can see 3 different rectangles, one at the bottom, second at the left hand side, and third on the right hand side. any issues finding the rectangles? And then for instance I'm taking them as equal. So let me say length into breadth and 3 times. They may be different, lengths will be given, and that will be your total surface area. So the story continues. We have a trapezium and we try to change it into a 3D shape. So volume is again cross-sectional area, and this is a trapezium. So cross-sectional area is 1 by 2 sum of parallel sides times height. This is the cross-sectional area multiplied with this length. This is my volume. And then when we talk about the total surface area, I can see 6 faces, one of which is 2 of these are trapezium. 1 by 2 into sum of parallel sides into height, this is 2 times, plus 4 different rectangles. So length into breadth, length into breadth, length into breadth, plus length into breadth, 4 different rectangles. Now how do you choose a regular side? If I draw this shape again, we had 6 different faces. Why did I choose the one which is already shaded? Now imagine you have this new candle and this is the thread. So when you light up this candle, what happens? It starts to melt, and when the top lid goes off, if I see it from the top, I can say that I can see a circle. When it keeps melting at the second stage, I can still say that I see a circle, but it is larger than the previous one. At this third stage, again I can see a circle from the top. It is even larger than those circles before. So this is not a regular shape because the cross-sectional area is changing. But what happens after these 3 cuts? Fourth one, fifth one, sixth one, seventh one. Each time now the cross-sectional area is same. So you need to choose that cross-sectional area which stays same throughout. For example, if I slice my shape, if I use a knife and slice it here, a new trapezium will appear, but it would have same area. Next slice, again a new trapezium, same area. Next slice, a new trapezium, same area. But what happens if we change the shape? If I choose this top layer as cross-sectional area and slice off this top layer, I still get a rectangle, but isn't the second rectangle larger than the first one? So in that case, this is not the regular side. So you always choose that side which is regular. For example, if we talk about a cylinder, so I have 3 options: one face, second face, and the third one is the curved part. So in this case, I know that if I choose the circular part as the cross-sectional part and I slice it off, I will always get a circle of same radius. So this is my cross-sectional part. So what happens to volume? Volume is area of cross-section, which is pi r square into height. So volume of cylinder is pi r square h. First thing. Second thing, total surface area. We have 3 shapes. This first part is pi r square. The second part is again pi r square, and the third part is the curved part, which is 2 pi r h. So total surface area is 2 pi r square plus 2 pi r h. Now there is another kind which are not regular. You will not find a cross section in them. For example, compare these two. We had a cylinder in which the volume was pi r square, that is area of base, times height. Compare this with this new cylinder and imagine that there is a point at the top, and we remove all extra things, leaving it in the shape of a cone. Now, can you find any regular side? Is there any slice you can make that stays the same area? The only difference in this case is volume is equals to pi r square h. You just add this 1 by 3. Volume of this shape is length into breadth into height. And imagine the same shape at the bottom, but it has a dot or a point at the top. So volume is same formula, length into breadth into height, but 1 by 3. Getting it? If I draw this semicircle, let's say the radius is 5 centimeters, and try to make a 3D shape and a height of which is 7 centimeters. So volume would be area of base times height. And do we agree the area of base is pi r square by 2 times the height? So its volume would be pi r square by 2 times 7. And what happens when we change this shape to this pointed shape? And keeping the radius same as 5 and this vertical height still 7. So volume is pi r square by 2, because that is the area of base, times the height, but with an addition of 1 by 3. This is the only difference. Last shape, I have this trapezium. This is my cross section. My volume was 1 over 2, side 1, side 2 into height. This is area of trapezium. This is the area of cross section times this length. This was the volume. What happens in the new shape, if the shape appears like this, there's the dot and it converges at one point. So the only difference is area of cross section stays there, 1 by 2, side 1 plus side 2 times height. This is area of cross section. Then we multiply it with the perpendicular length, but because it is converging at one point, this is the only addition. So every formula stays same, but you add 1 by 3 to it. Talking about the volume, we are left with perimeters. So let's go backwards. I can see 5 shapes. One is the trapezium, and then there are 4 triangles. So I already know how to find the area of trapezium and triangles. We will find 5 different areas separately and add them. In this shape, I can see 1 square at the base and 4 triangles erected. In this shape cone, I can see one shape at the base and the curved part. This is pi r square and this curved section is pi r L, where L is the slant height. This is the perpendicular height, L is the slant height, and you will have to use Pythagoras theorem to get through it. Radius and height using Pythagoras theorem to get the slant height. Let's go through few questions. Any shape if you want to ask, if you're thinking of any. If you think I've missed one. I think we haven't discussed kite, but that's an easy one. Quickly. Kite is just a composite shape which contains two triangles. So you find the area of these two triangles separately and then add them. What about the perimeter? You add all four sides, 1, 2, 3, 4. And then if we talk about this sphere, formulas for 3D shapes are mostly given. Volume of sphere is 4 by 3 pi r cube. Area of sphere is 4 pi r square. Now this would be given, but what if this appears in exam as hemisphere? What will be the volume? Anyone? 2 by 3 pi r cube, that's right. And area? 2 pi r square. Anyone disagrees? Shabash. Plus pi r square. But remember, if you have this apple and it is all red at the outside, so the area is 4 pi r square. But when you slice off this apple in half, you get half of the red area, which is 2 pi r square, and half of the white new surface, which is a circle of pi r square. So it becomes 3 pi r square ultimately. So whenever you're given different shapes, first analyze it and then write the formula.